this is our project on stock market analysis system where we use CSV files. We did not retrieve the data from an API. We created the data. We have 30 different files, CSV files for this data. And when each of these files has 100,000 rows, where it has 5 to 6 different columns showing data such as open, highs, lows, close, and volume. It also is sorted by date. Okay, it's not sorted by date. Right now it's randomized, but then we use different data structures to sort this data. I'll just go through the backend right now, where we have different files, such as stock data processor. This file contains different functions. Read CSV is basically just a function that reads the CSV file and stores that into a vector. Puts the whole file into that vector, and after that we have this function, which basically just pre-processes the data and gets rid of any repeated data or trash data. After that, we have the calculate average close function and this print data function, which is just there for debugging purposes. I'll go over merge sort CPP. This file is containing code that is going to be used to basically just sort the dates of the CSV files in a chronological order. So I'll show you guys now how it looks. This is the first one that is unsorted, and after we actually do sort this file, it's going to look something like this, which starts from the first date of 2023 and it should end with the last date of 2023, which is 31st of December. Okay, I'll just go with the different files now. CPP, heap CPP is basically the same as merge sort CPP, but obviously it contains the heap sort function and the heapify function, and also the swap rows function, which is used to sort the data in those files. And after that, we also have the performance file, which contains the different functions that will calculate the metrics using the data inside the sorted files that we will sort using merge sort and heap sort. And it also has different helper functions such as calculate daily returns and the aggregate by data function that are basically helping those functions to calculate those metrics. After that, we have the merge sort time function and the heap sort time function, which basically just calculate the time complexities of the merge sort function and the heap sort function, and that's about it. I'll go over the front end now, which basically is output like this. It's using HTML, CSS, and JavaScript to basically just output the data in a nicer way and organize it. HTML creates the web structure, CSS actually styles it, and JavaScript would actually be the stuff that is used in the backend to make these graphs and basically just output this. Anyways, now Diego will go over what this actually outputs.
Yep. So there's a list of the companies on the left side with some buttons, and you can select 2 of the companies. And after selecting them, you can obviously click compare. And this prints out most of the results, which includes our heap sort time and the merge sort time, which is how long each sorting process goes to the back. Takes when in the back end. And yep.
That's about it. Now Haya will explain now what the Sharpe ratio is and the total return is, and also what these graphs are outputting. So yeah.
Okay, so the Sharpe ratio, it essentially divides a portfolio's excess returns by a measure of its volatility to assess risk-adjusted performance. Basically, what this means is that you're comparing how much extra reward you get from something to how much risk you had to take to put into it. I'm sorry, you had to take to get it. And then we want a higher Sharpe ratio. As for the total return, that's just the overall gain or loss of an investment over some kind of time. And it includes both capital gains and just income that's generated. And this strategy specifically is geared towards producing the highest possible return on investment. And then if you look at our graphs and then also the recommendation, it outputs what the better company would be. And yeah, again, just the graphs is a visual of that.
That's our project.